This video will demonstrate how to assemble and connect a general railway signal model to a Semaphore circuit controller, as well as how to integrate it with the Semaphore itself. Now I'm examining the reasonings for disassembling the circuit controller in the previous video. Both the frame and the drum cogwheel had to be replaced. The drum and frame showcased in the previous video, here in my hand, had undergone a brazing repair, which unfortunately did not hold up. This is a replacement frame that I had in my parts pile that was rusted like a Cheeto. This whole one ear was brazed as well, and that's why that lug in the disassembly video was loose. And I will be using that frame with the loose lug to set up a 3-position circuit controller with drag contacts. So look forward to that. Thomas Kyle provided me with a paint code that he obtained by scanning mint condition vintage parts that he has in his new old stock collection. He matched this code with the PPG product range. The paint is the Shopline series and is labeled Madura Red with a product code of 51024. Big shout out and thank you to Tom for providing me with that paint code. If you're looking for an exact match to the original paint, go with the satin finish. I went with gloss. That's my personal preference. You can do whatever you want to do. If you're going for 100% originality, I recommend the satin. I'm making this video because this seems to be a common topic of discussion, is how to wire these things, and there's a lot of them that are out there wired incorrectly, and I'm not saying I am the expert on wiring these things. As a matter of fact, take everything I'm saying here as hypothetical, and I am not liable or assuming responsibility for anybody that damages their equipment. I'm just showing you how I do it. Also, another good point of reference here is Zach Gillingham's website, railroadsignalpics.com. He has great documentation there on how to wire them. I print them out so I can have them while I'm working. And then if I get them all dirty, I don't have to worry about ruining the originals. So thank you, Zach, for doing what you do with that website. This is a great reference here on the orientation of the gears in the circuit controller, because this is also something that can really throw off how you set up your contacts in your controller. And then for the snap contacts for the high voltage motors, the placement of these will really get you in the ballpark from the jump, which you'll see more about later in this video. So, alright, let's go over a little bit of how this works, because snap contacts are one of those things to where it took me a long time to understand. I'm pretty sure Rob Connor had to explain it to me 100,000 times. So this drum you saw in the disassembly video has a pin that goes through the shaft. So this drum with the pin, it always stays keyed to it. Now the snap contact drum catches up with the gearing at the end via the spring. Well, what does that mean? It's easier just to show you. So it doesn't spin with the gearing. The only thing that's holding that on there would be the spring that mounts to the end of this shaft. So where's the spring? This here is the spring. And I will move this out of the way to illustrate how it works. If you have a good way to get these off of here without slingshotting them across the room, let me know. I haven't figured it out, nor have I tried. But as you can see there, the fingers move out and then it catches up. There's a key on here, and it goes on there. And that's how it stays in position with the drum. And then the fingers go in that tab on the drum. Let's see if I can get that set up. Okay, so as the drum's moving along, these will lock in to hold the drum in a position to create the contact of these fingers that carry the power. And so the drum will be moving, and then it'll get locked up, and it'll have the current being, and that'll complete the circuit. And then once the bumps on the snap contact come along, on the end, they'll knock the fingers out. Show that in greater detail after we assemble the controller. Alright, so let's actually build the controller. First we're going to build it to go to a 2 position, and then we're going to do basically the same thing over again, but for the 3rd position. So I always build these just going off of one side. You can certainly use both sides of the drum. How I set these up is I always have the gear facing away from me, snap contacts towards me. The orientation is important here. This pin is directional, and it actually, let's see if I can, it has a taper to it, so it will only come in and out one way. And I got it on the first try. Cool beans. So our hold segments are going to go on the main drum there that is pinned to the shaft way. And then our 45 and 90 segments are going to go on the little drum there. So, and then I'm referencing this to get my correct start angle. And this is like as if this is 180 out from how it's supposed to look in my hand, because this is as if you're looking through the back of the controller. So right about there. Flipping through our documentation here. If somebody knows the correct way to measure this stuff, let me know. I don't know. I don't claim to know. Looking at what this says is the 90 snap cutoff is 1.6875. I got 1.8. Two. Something else 1.8. All right, so I'm going to go with this one for my first one. There's about 3/8 of an inch of adjustment in the fingers, so I'm not super concerned about it. We got our first first segment. These are called segments in here, and now we need to figure out where our hold contact is going to be. So I went ahead and assembled this. This is going to be our first finger. This is going to be our second finger. These are going to be jumpered together to complete the circuit, and you'll see here why in a second. And this is going to be our hold coil. So how this works, clear this stuff out of here. So as this works is the drum, this is a segment here, and as that moves forward, when that moves forward, then there's going to be a break in there, and then all this is going to be connected. And when those are connected, then you have, let's say, what would this be? This would be positive. This
So
would
the
be
left
negative.
finger contact is the motor power. When that breaks, the motor shut down. And the right contact is your hold for your hold coil, so that it'll hold in the 45 position.
So, and it would go this way, this way. Well, actually current flow is the other way, but you get the idea. We have this segment, so now we need to advance this to where it's just past where the fingers are going to be, and then we need to put our segment for our hold on there. I like using the smallest possible hold contacts I can. I don't like hearing the hold run for forever. Let's try that.
Okay, so put this guy on. Let's see how we're faring. Oh, this might make more sense if I actually put the jumper on there. So those wires are jumping together. Everything railroad signals is washer, wire, and then washer. Okay, so yes, I believe this is Okanite 16 gauge. If you want to buy something from Okanite, it's $4 a foot. Expensive stuff. No one had added these studs down here for when we take it to the third position. We'll do the same on this. I would do every other one, just because that's how the custom setting up. But you could certainly put all your old contacts right next to each other if you wanted. There is no rhyme or reason to this. You can do it however you want.
This is a General Railway Signal Model 2A dwarf, custom made for the Grand Central Station in New York City. Designated as signal number 538, Cody McCoy pointed out to me that this signal was used as in the upper level of Tower C. The spectacle is a recast and the blade is a replica. Lamp unit is also a replacement to the signal. Aside from these parts, everything else remains as it was when taken out of service. The signal has never been exposed to the elements and retained its original condition. I have no plans to restore the signal further than the replacement parts that have been placed on it to make it operational. The signal sat in storage for a number of years before I acquired it. The signal's great for setting up circuit controllers because you can set up the circuit controller with the signal on the ground and then go deploy it on a tall signal. I currently have the original motor out of this signal, and I have it set up with a low voltage motor because that's the type of controller I'm trying to build today. All right, so on these motors here, this neutral post is usually the common. So we will set that up for negative. Green is negative. These two are going to be your hold coil, which you'll be able to see the little latch down here move when I give them power. So that is your high power, because you can see it's drawing almost half an amp, 0.38, almost 0.4 of an amp. Now at 0.4 with the low voltage coil holding in. So that's something interesting to note, and this is what gets screwed up on a lot of these. The 0.16 amps that this coil, low voltage coil or low amperage coil is pulling, that it does not have enough oomph to pull this little flapper. That's where this one comes in. But since these low voltage motors were battery operated, you need to configure the controller to where this high voltage coil drops out at a certain point within the controller. And I will show that here soon. And then this is coming up out of the motor. That's the power for the motor. All right, so let's go two positions. I'll put the controller in here and I'll bring you guys back. Before we fire this up, we do have to add our snap contacts. Otherwise that spring will go flying across the room. Boom. Okay, so we have a snap contact, and then we have to put our segments in here. And no, I'm not just guessing on placement for these. This one's a little boogered up. The placement I got from our documentation off of Zach's website. Okay. All right, now we are set to wire in our controller. All right, so this is power the motor, high voltage or high amperage coil, power the motor. I'm gonna put those all on the same post because we want those to drop away as the segment moves forward. All right, now I want the low amperage coil to stay powered in after the circuit is completed. So I'll put that there. All right, let's give her a go. All right, so it didn't go far enough to complete the circuit. So advance this one tooth. Okay, so I'm really not happy with this snap contact choice I made. I'm going to move it down another segment. Okay, so I'm switching out the snap contacts. This is the one I had in there. This is the one I'm changing to. I'm not double washering and nutting these because it's just temporary. I'm going to take this controller out to make it go to the third position. Put the cotter pins in. Just in case. All right. So it's important to note the power draw. And that's what you want to see. You do not want to see it pulling half an amp. Should also buffer on the drop like that. Well, congratulations, you've wired a GRS 2A semaphore to go to 2 positions. So now I'll go over wiring it to the 3rd position. Okay, so now we want to do the same thing, just again. So we want another contact, so let's get that to where it's cleared. So it'd be somewhere there because we know the hold coil will be holding. And then these are going to be our advancing holes. It looks like this has been punched several times here. All right, so already made up a whip. We need to add our fingers. And then I'm just going to go with the same style segment that I just had.
Alright, so go bottom hole there. That looks good. Alright. Get that on there. This side. These will hold your finger in position, so that's the reason it's playing. That's why I was referencing is the waffle holes in there. Okay, so we know we need to jumper these guys. This to here. Again, we're doing the same exact thing we did do 45. That's 90. Well, we gotta add our segments. So let's advance that all the way. Alright, so I'm looking for a little guy.
Alright, so the way that these segments work, that since they advance out of position and we still need to give motor power and we still need to give the coil power, what we can do is just jumper these positions together. Instead of using little wires, I'm going to use these little copper plates to tie the terminals together. Let's make sure these are tight. And that's it. You've made a controller that'll go to 90 in theory. Let's give it a try. Alright, again, to go over this wiring real quick. Neutral for motor, bottom right coming out of the coil housing goes to the neutral on the motor. This is for a 10-volt motor. Other side, power to the motor, positive. And then these are your coils. Lower right on this motor is your low voltage coil. The top is your high voltage coil. Benchtop power supply is the easiest way to tell what your draw is, to make sure you're wiring it correctly. And then as far as placement of the controller on here, I always go to where this is almost vertical, and then I advance it a little bit, and then I try and work it on the signal. That's probably a little advanced. Alright, let's try that. And that's just setting the gear mesh into the gear train. It makes a big difference. If that's unclear. Alright, so now we gotta wire this back in. So, I know that this is my low voltage coil, so that goes here. let's say you had like a Chicago Northwestern, you could just add another contact, but to the other side of the drum or wherever, you could be right here to where you needed the star markers to light up. You could just add more fingers and more contacts to do that. Alright, so this is high power coil. And this is high power motor. Well, just power the motor in general. I'm not putting anything on here permanently, so again, I'm not double knotting or washing anything or anything like that. So 45. That's a little off. I think we're at I think it's a tooth advance right now. Let's bring you guys around for do that. You can see still at an angle a little bit. Which is what you want. That is the correct gear mesh right there. Alright, so 45. Okay. Our 90's not touching, so I gotta adjust the fingers on that. Alright, so let's go to 90. Alright, so I adjusted the snaps there because the snap contact never catched because where this bump out was pushing the snap out before the wheel could catch. Alright, let's go 45. So you can see how snap contact works there. Alright, so now we want this tooth to catch, so we can go to 90. Alright, so our hold contact is not engaging. Alright, so kill it right now. And then between these two contacts, you can put a switch in line after you hook up a power supply. All right, so that's as far down as that finger will go. Right. All right, so I ended up having to change that segment placement in the very last position for the 90 for the hold coils. All right, so let's go 45. Locked in. You see how that drum sticks in position and then advance when these arms come out. That's what makes the snap contacts possible. The snap contacts are designed for the high voltage motors. They're not particularly useful in the low voltage applications, even though you still see the arc.
And for this to drop correctly, you're supposed to there'd be shunted across there. At this. So snap contacts work on the up and the down. All right, 45. 90.
Five. Congratulations, you've wired a 3-position GRS 2A Semaphore controller.